Hello. So today we're going to discuss how to find out the number of terms in a binomial expansion. So picking up from lecture number 1, so we found out the given a binomial expansion x plus a raised to the power of some positive index a, then when we expand it we get nc0 x raised to the power of n times a raised to the power of 0, which is 1, so I'm not writing it here, plus nc1 x raised to the power of n minus 1 times a. Then the third term will be nc2 x raised to the power of n minus 2 times a squared, and so forth. Then if we replace a by negative a, then we can also find out the expansion of x minus a raised to the power of some positive index n. Then this would give us nc0 x raised to the power of n. The second term will be negative, so nc1 x raised to the power of n minus 1 times a. The third term would be positive, nc2 x raised to the power of n minus 2 times a squared, and the fourth term will be negative, and so on. Okay. Now the question is, what's the number of terms? Let me rename it. Let me call it equation number 1 and equation number 2. Now, to find out the number of terms, what we simply have to do is take the positive index n and increment it by 1. So that would give us the number of terms. So it doesn't matter if n is even or odd. So I'll write here for both odd and even values of n. For example, twice x plus 3y raised to the power of 7 has 7 plus 1, which is equals to 8 terms. And another example will be x over 2 minus 2 over x raised to the power of 10 has 10 plus 1 equals to 11 terms. So far so good. Okay. So we can easily find out the number of terms for any index n, for any positive index n. Now what we do is we're going to add 1 and 2. So we're going to add equation 1 and equation 2. So that should give us x plus a raised to the power of n plus x minus a raised to the power of n on the left hand side. Now on the right hand side, you can see that the first term for both the two equations are exactly the same. The first term is exactly the same, so they add up to give us twice nc0 x raised to the power of n. And when we add the second term of equation 1 and 2, they're going to get cancelled because they are additive inverse of each other. So we'll get 0 in the second term. Then we move on to the third term. So the third term will give us 2 times nc2 x raised to the power of n minus 2 times a squared. The fourth term will get cancelled. Then we'll move on to the fifth term. So the fifth term will be 2nc4 x raised to the power of n minus 4 times a raised to the power of 4. Okay, now what we're going to do is we're going to subtract 2 from 1. So when we do that, what we get is x plus a raised to the power of n minus of x minus a raised to the power of n. Okay, now the first term will get cancelled out. The second term, which is nc1 x raised to the power of n minus 1 times a in equation 1, minus nc1 times x raised to the power of n minus 1 times a. Second equation should give us 2 times nc1 x raised to the power of n minus 1 times a. Okay, the third term is going to get cancelled out, so we move on to the fourth term. So the fourth term will be 2nc3 x raised to the power of n minus 3 times a cube, and so on. So we get this two new expression when we add 1 and 2 together. So that's give us, let me slightly go. So this gives us a third equation, and when we subtract 1 from 2, when we subtract 2 from 1, we get the fourth equation. Now the question is, what's the number of terms in equation number 3? I can say in the expansion of x plus a raised to the power of n plus x minus a raised to the power of n. So we have two cases, one odd case and one even case. So we'll do the odd case first. So in the odd case, when n is odd, so when n is odd, the number of terms can be found out by using the formula n plus 1 over 2. That is, for example, if I am given the expression 2x plus 3y raised to the power of 7 plus twice x minus 3y raised to the power of 7, so the number of terms would be 7 plus 1 over 2, which is 7 plus 1 is 8, 8 over 2 is 4, so there will be 4 terms. Similarly, if I have another expression, let's say this time thrice x minus 5z raised to the power some even integer 8 minus, this should be plus, thrice x plus 5 of z, so thrice of x minus 5 of z raised to the power of 8, then what should be the number of terms? The number of terms would be, the number of terms will be equals to, oh, my mistake, I should have taken an even number here. I should have taken, because I'm on the odd case, my bad. So let me quickly rewrite it. So this is thrice x plus 5z, let's take it 13, minus of thrice x minus 5z raised to the power of 13. So the number of terms, will be equals to 13 plus 1 over 2, so it is 14 over 2, so we'll get 7 terms. So this is how we find out the number of terms for the two cases. Now we come to the even case. So in the even case, again we'll have two more cases. So when our n is even. Now for the first case, which is x plus a raised to the power of n plus x minus a raised to the power of n. So when n is even, now for this particular case, the number of terms can be determined by using the formula n over 2 plus 1. So that is to say, if I'm given the expression twice x plus 3y raised to the power of 4 plus twice x minus 3y raised to the power of 4, then we have the number of terms. The number of terms will be equals to 4 over 2 plus 1, which is 3. So then we have 3 terms. Now the other case, in the subtraction case, so right here. Now for the next case, for x plus a raised to the power of n minus of x minus a raised to the power of n. The number of terms will be given by the formula n over 2. So for example, if I have twice x plus 3y raised to the power of 4 minus twice x minus 3y raised to the power of 4, then my number of terms must be simply 4 over 2, which is equals to 2 terms. That's it. So let me rename it. So this is number 1, this is number 2. So this is how we can find out. We can find out the number of terms for the given expression. So let us work on some problems. Let me write here, worked out problems. So our first equation would be twice x minus 3y raised to the power of 9. So we have to find out the number of terms in this binomial expansion. The binomial expansion of 2x minus 3y raised to the power of 9. How many terms are there? So here we can clearly see that the value of our index is 9, which is odd. So number of terms, it doesn't matter if it's odd or even. The number of terms is simply given by 9 plus 1, which is equals to 10 terms. That's it. Now go to the second problem. So we have 1 plus 5 square root of 2 times x whole raised to the power of 9 plus 1 minus 5 square root of 2x whole raised to the power of 9. So we have to find out the number of terms here. So first we begin by writing the value of n. So n is 9, which is an odd number. So this is an odd number case. So to find out the number of terms, we use the formula n plus 1 over 2. So this is 9 plus 1 over 2, which gives us 10 by 2. So there will be 5 terms. Okay, now we move on to the third question. Root over x plus root over y whole raised to the power of 10 plus root over of x minus root over y raised to the power of 10. So here we have n is equals to 10, which is an even number. So this being an even number, so we'll apply the formula. So let's go back. So what was our formula for even case? So this is n by 2 plus 1. So this is the one, n by 2 plus 1. So number of terms would be 10 over 2 plus 1. So 10 over 2 is 5 and 5 plus 1 is 6. So we'll get 6 terms here. Great. Moving on to the next one. Question number 4. It's twice x plus y whole raised to the power of 8 minus twice x minus y whole raised to the power of 8. Again, we have a case where n is an even number, n is 8. So now we apply the other formula, which is n over 2, to find out the number of terms. So number of terms is given by the formula n over 2 So we have 8 over 2, which is equals to 4 terms. Okay, so let's do one final problem. The final problem is question number 5. 1 plus twice x plus x squared raised to the power of 20. So we have to find out the number of terms. Now be careful here. The number of terms in the above binomial, in the binomial expansion of the above expression is not equals to n plus 1. That is, it's not equals to 20 plus 1, which is 21. Why? The reason being 1 plus 2x plus x squared. This is a trinomial. This is a trinomial expression. We are doing binomial expression, binomial theorem. So we need a binomial expression in order to be able to apply the formula n plus 1 in order to determine the number of terms. So what we need to do is, if it is possible, we need to convert this into a binomial expression if possible. Now in this particular case, it is possible to convert it into a binomial expression. The reason being, this is equivalent to 1 squared plus 2 times 1 times x plus x squared. Now which is equivalent to the identity a plus b whole squared. So 1 plus 2x plus x squared can be rewritten as 1 plus x whole squared. What we do is we replace the trinomial by the binomial. 1 plus x with the squared raised to the power 20. Now the law of exponents states that whenever we have a power over a power, they simply get multiplied. So we have to take the product of 2 and 20, which gives us 1 plus x, 4 raised to the power of 40. Now we have a new n. Which is 40. This implies the number of terms equals to n plus 1, which is equals to 40 plus 1, 41. So we'll have 41 terms. So this was all about finding the number of terms in the given binomial expression. So like the number of terms in the binomial expansion of a given binomial expression. Okay. See you in the next class.